In this video, we'll discuss training and validation. Overfitting is when our model fits the noise or an outlier. Let's help explain this with a little example. Consider the following data points. We have the actual line generated in blue and the training points in red. We see that this set of data doesn't really follow the underlying pattern. This is an example of an outlier. We usually split our data into three parts. The training data, the validation data, and the test data. We use the training data to obtain model parameters. For example, our slope and bias. We use validation data to obtain hyperparameters, such as mini-batch size and learning rate. Our training data is used to minimize a total loss or cost function explicitly. Our model also depends on hyperparameters such as mini-batch size and learning rate. Let's clarify this with an example. Let's use two different learning rates to train two different models on the same training data. We use the first learning rate and we obtain our model. Then we use the second learning rate to train the model and we obtain the actual model. If we look at the total loss or cost surface, we see that this model seems to perform better as it comes closer to the minimum, so we select this model accordingly. This can be a sign that the model is fitting the noise or the outliers associated with the data, not the underlying pattern. So to determine the best hyperparameters and associated model, we use our validation data. Let's clarify this with an example. We use our validation data to compare two models. We do this by calculating the cost or total loss on each model. Let NV be the size of the validation set. We use our initial cost function with the first model, and we get a cost value of 100. Then we test our second model, and we get a cost value of 50. We then select the model with the lowest cost on the validation data. In this case, it's model 2. This contradicts the results we got in our test data where model 1 performed better. This can be a sign of overfitting. Let's do an actual example. We have one sample, and V equals 1. Calculate the cost for the first model, and the result is 256. And we do the result for the second model, and the result equals 0. And we pick our second model. The following plot shows the total cost for the validation and training data for different learning rates. The loss on the validation data is usually higher than the loss in the training data. This plot shows our data points and our true line, f of x. The following line minimizes our loss on our validation data. As you can see, it is very close to the actual line. This also corresponds to the line that maximizes the total loss or cost on the training data. This line is obtained by the maximum number of iterations. You can see it minimizes our total loss or cost on our testing data. When our model performs extremely well on our training data and extremely poorly on our validation data, this implies overfitting, where our model is fitting the noise or the outliers. We'll clarify this later with more complicated models.